All right, we're on our last commonly seen free response question type. So this gives us 6 total. And at first, we'll just look at 2 in class, and then we'll start looking at just a random FRQ, identifying which type it is, what's important for that type of question, and how to answer all of the parts. All right, so this last part is differential equations. Generally, you'll see a slope field, or you'll see like the word differential equation in it. So there's like the giveaways that it's this type of problem. All right, so keep in mind some things. If they say general solution to a differential equation, that's when the plus C is there. Because general, you don't know what the value of C is. Particular solution, wow, that was not a good underlining job. Particular solution, you know the exact value, you have to figure out what C is. So that's the only difference between general and particular. If it's asking you to solve a differential equation using separation of variables, get the y's on one side and the x's on the other. And actually, I think it's interesting when they tell you to solve, a lot of times they say solve by separation of variables. So sometimes they tell you exactly how you're supposed to solve it. You have to know all the intermediate steps, so they're kind of telling you that first step. And then exponential model, if this variable is just a constant times there, its answer is an exponential model. All right, so that'll save you a lot of time if you're trying to do something with an exponential model. You can solve it using separation of variables, it's just more work. All right, so if you look at this question, this was from the 2022 exam. And right away, I haven't even read anything. I know it's a differential equation question because I can see this big slope field here. But they give you the differential equation. There's a particular solution, has initial conditions 1, 2, and now we have the parts. So the first part is use the slope field to sketch a solution curve. So remember a solution curve, they even put the dot on there for you. You just follow the lines, which direction they're sending you. All right, that's the general solution curve. So part A, if your curve looks like that, you get 1 point. Now, this is the exact one, but again, if it has kind of the 2 humps, then you're going to get credit for that. All right, part B, write an equation for the line tangent to the solution curve at 1, 2, and use the equation. So remember, you're making a tangent line. You need 2 points. You need or 2 things, a slope and a point. They give you the point. How do you figure out the slope? Well, the differential equation, the derivative, is just a bunch of slopes. So if I put in the point 1 for x, 2 for y into my differential equation, I get 3 halves, and that's the equation of my tangent line. All right, using point slope form, y minus y1 equals a slope times x minus x1. And of course, I just added the 2 to the other side. All right, so that's the slope of my tangent line. That's 1 point. Pretty straightforward if you know how to find the equation of a line, just a slope and a point. And then I want to use this line to approximate 0.8. So I'm just going to put 0.8 in for x, and whatever my calculator gives me is my answer. Actually, this one might not be a calculator question, but again, you could leave your answer like this because it's algebraically equivalent to that. So again, so you can, if you only wrote this, you would just get the second point. That's interesting. So yeah. Oh, because part of the thing is write the equation for the tangent line. So you actually need to answer that question. I just noted that the second derivative is bigger than 0 is the approximation found to be an overestimate or an underestimate. So if something is, the second derivative is bigger than 0, what does that mean? It means it's concave up. If I put a tangent line on something that's concave up, am I going to get an overestimate or underestimate? Well, everything is above the tangent line. So it's it's an underestimate because my line is under my graph. That's basically write that whole thing out as a sentence. That's 1 point. And then part D, see they say use separation of variables. So they're kind of telling you how you should solve it to find the particular solution. So using the separation of variables, even though they tell you how to do it as 1 point, get the y's on one side and the x's on the other. If you get 1 correct antiderivative, you get 1 point. So if you could only take the derivative of the right-hand side, you get 1 point. If you got the derivative of the left-hand side, you get 1 point. Taking the derivative of both, you get 2 points. Once you've correctly taken the antiderivatives, you need to solve for c. So you plug in 1 for x and 2 for y. That'll give you the third point. In the very end, now I need to get y all by itself. That's a last point. 1, 2, 3, 4. So 5 out of the 9 points are here. Maybe you can only do step 1, and maybe you mess up the derivative, or sorry, the antiderivative after that and everything. But if you get this 1 point here and the other question's right, then that gives you 5 points out of the 9, which is still good. But chances are, if it's a differential equation FRQ, solving the differential equations, giving the majority of the points. So we set the practice, our separation of variables, should be the straightforward step, and then just making sure we can get antiderivatives correct. All right, these two antiderivatives aren't super complicated. The antiderivatives you actually have to do are never like 20-step antiderivatives. It's just things you have to be careful with your coefficients and stuff. So making sure you get your coefficients in the front, things like that. All right. They're never trying to like stump you with a really hard antiderivative. They're more concerned of, do you know how to do basic antiderivatives, and do you know how to apply them to a question like this? All right, so these are all the major questions that come up. So now we have all 6 of the main FRQs. Chances are all 6 are going to show up. Worst case scenario, 5 of them show up, and there's one extra FRQ that's not directly related to any of these 6. All right, so some topics that might come up as a different FRQ. That doesn't happen every year, but it's possible. You could see an implicit differentiation question. So it'd be like 2xy equals y plus x, and ask questions about its derivative and things. You could do related rates. We actually saw one of the examples we did in these videos. Related rates was like a part of a bigger question. So again, it might not be a whole question, but it might be a part. Families of functions, so asking questions about exponentials and things, and then a L'Hopital's rule question might also pop up. Generally, this is also just a part, like part B. They'll say like f of x is h of x over g of x, and what is the limit as this versus 1 of f of x? It's just like a single part would be L'Hopital's rule. This is another thing that might come up kind of randomly that's not directly related to these types of FRQs we saw. But again, even if this was part like D in question 3, and this was part D in question 5, if you just got those 2 wrong because they're kind of coming out of nowhere, they're not directly related to our types of FRQs, you can still get a lot of points on your free response questions. All right, so now we have all 6. Again, our first day in class, we're just going to focus on the 2 new ones. So differential equations and the video before this, which I can't remember right now. So we'll just focus on those 2, do a few practices of that, and then after that class, now we'll have all 6 of our free response questions. We'll just look at a random free response, figure out which grouping is this in, what's important, how do we answer the question. So by the end of the unit, we'll see like all the free response questions from the last 5 years of the AP test. I want to know like the common things that are coming up, the things that are like non-negotiable that you have to get right in order to do well enough to pass.